All right, let's get into it. We all eat fatty foods, and we kind of think we know how our bodies deal with them. But what if I told you that deep inside your gut, there's a secret chemical shuffle going on, a molecular dance that completely changes what we thought we knew about digesting fat? Yeah, it turns out the whole process isn't nearly as simple as just breaking things down. There's a plot twist, a little sleight of hand at the molecular level that scientists are only now starting to fully understand. So let's pull back the curtain and solve this digestive mystery together. Okay, so first things first. To really get why this is such a big deal, we have to start with the official story. Let's cover the simple, textbook rules for how your body is supposed to handle the fats you eat. So, the main player in this whole drama is a molecule called a triacylglycerol, or TAG for short. The easiest way to picture it is like a keychain. You've got this central glycerol backbone, that's the keychain itself. And attached to it are three fatty acid keys at three very specific spots. Now, the old rulebook says digestion is a pretty clean two-step job. First, these enzymes, called lipases, act like tiny, precise scissors. They come along and snip off the two outer keys, the fatty acids on the ends. But the middle key? That one gets left alone, still attached to the keychain. And that whole piece gets absorbed by your body. So this is the crucial part of the old story, that middle fatty acid is considered totally protected. The enzymes are basically programmed to ignore it. It's supposed to be safe. Simple enough, right? Well, yeah, not quite.
And this is where things get really interesting, because when scientists took a closer look, they found something that just didn't make sense, something that seemed to break the very rules we just talked about.
You know, a 2025 paper in Food Chemistry Advances just nails it. They start by saying, yeah, everyone agrees the middle fatty acid, or FA, is supposed to stay put. But then they drop this little breadcrumb. This process called isomerization could actually be the thing that sets it free. And that right there is the big mystery. If that middle fatty acid is so protected, why on earth were researchers finding it cut loose and floating free after digestion? It's like finding a prisoner walking around outside a locked cell. You know something else must have happened. So, what is this secret backdoor? What's going on? Well, it all comes down to something we're calling the Great Fatty Acid Shuffle. And this, right here, is the aha moment that solves the whole puzzle. Okay, so the fancy scientific term for it is isomerization. But honestly, shuffle is the perfect word for it. It means that during digestion, a fatty acid can literally just pick up and move from one spot on that glycerol keychain to another. It just shuffles over. So picture this. Before the shuffle, our little fatty acid is sitting there, all cozy and safe in that protected middle spot. The digestive enzymes are circling, but they can't get to it. It's totally off limits. But then, bam, the shuffle happens. That fatty acid hops from the safe middle position to one of the vulnerable outer spots. And once it's on the outside, it's fair game. The enzymes can swoop right in and snip it off. And just like that, our mystery is solved. Now look, a cool theory is one thing, but you gotta have proof, right? So let's head into the lab and see how the researchers behind that 2025 study proved that this shuffle isn't just an idea, it's a real part of how we digest food. So the team built this amazing setup that basically mimics the human digestive system, and they tested two things in it. First, a specially made fat where they knew exactly which fatty acid was in the middle, and second, actual cow's milk to see if the shuffle happens in a real, complex food. And the results were just wild. Using their model fat, they found that nearly 26%, that's more than a quarter, of the supposedly safe middle fatty acid got snipped off. This was the smoking gun. It proved the shuffle and snip was happening, and way more often than anyone thought. Then they looked at the real milk, and here they found something just as convincing. They measured the amount of free glycerol. You know, the keychain without any keys. The only way to get that is if all three fatty acids get cut off. And they found that 10% of the fat was completely broken down this way. That's only possible if that middle fatty acid shuffles out of its safe spot. But here's where it gets even cooler. Not all fats shuffle the same way. The researchers found that medium-chain fatty acids, the kind in coconut oil, shuffled like crazy, about 33% of the time. Polyunsaturated fats were next, around 21%. But those long-chain saturated fats, the kind you find in a lot of animal products, they hardly shuffled at all, only about 11%.
So the type of fat you eat really, really matters.
Okay, so a molecule does a little dance during digestion. Big deal, right? Why should you actually care? Well, it turns out this discovery has some pretty huge implications for nutrition and how we should think about the fats we're eating every day.
So let's just break it down nice and simple. The fats that are more flexible and shuffle easily, like medium chain and unsaturated fats, they get broken down much more completely. On the flip side, those more rigid fats, the long chain and saturated ones, they tend to stay put. This difference in their willingness to shuffle has a direct effect on how they're absorbed and used by your body. So, what's the takeaway for you? Well, it means the structure of the fat you eat is just as important as the type of fat it is. The shuffle literally changes how quickly and completely fats are broken down. It tells us that digestion isn't some rigid assembly line. It's a dynamic, constantly changing process. The old textbook version, it's just way too simple. And all of this leaves us with one last pretty big question to think about. If the very molecules in our food can change their shape and rearrange themselves once they're inside our bodies, how does that change the way we think about food itself and the incredible journey it takes after that first bite? It's definitely something to chew on.